Well, we are trying to solve this limit as x approaches 0, e to the power of alpha x minus e to the power of beta x over sine alpha x minus sine beta x. Here alpha does not equal to beta because we don't have 0 at the bottom. So that is perfectly legal. So first of all, I observe the bottom and top. Realize that as x approaches 0, both the top and bottom will approach 0, right? So e to the power of, for example, 0. So that's 1. 1 minus, still 1, 0. And sine 0, right? 0. 0 minus 0 still. So it's 0 over 0 type. So it's okay for us to use L'Hopital's rule. So let's differentiate both top and bottom. So now I have alpha e to the alpha x minus beta e to the beta x over alpha cosine alpha x minus beta cosine beta x. Now let's check if it's still 0 over 0. If that's the case, we may have to reuse the L'Hopital rule, right? Repetitively use it. As x approaches 0, what will happen now? So if x approaches 0, e to the alpha x approaches e to 0, approaches 1. So that approaches alpha. Similarly, this approach beta, alpha minus beta, non-zero. So this is cool. So this one, x approaches 0. Cosine alpha x approaches cosine 0. Cosine 0 approaches 1. So this approaches alpha. Likewise, this approaches beta. Right, so alpha minus beta. The same amount as the top. So really this approaches alpha minus beta, which is equal to 1 as x approaches 0. So it looks like we're done. So really that limit is equal to 1 as x approaches 0. Now there is a second method. So the second method, I will be using Taylor expansion. So first, notice that e to the power of x can be written as 1 plus x plus little o of x squared. This remainder is called piano remainder, nearby the point where x is equal to 0. So I'll explain what little o of x squared means. So we're going to use this lemma as well. The angle sum transformed into angle product. So the trig sum transformed into trig product. First, I'll prove this quickly. So sine of a minus sine of b is equal to sine of half of a plus b plus half of a minus b minus sine b can be written as sine of half of a plus b minus half of a minus b. And then we can use the angle sum formula, right? Sine cosine plus cosine sine, sine cosine minus cosine sine. So in the end, sine cosine cancelled out. We're only left with cosine sine. And we have twice of that. So twice of cosine sine. So we have this result. So that means I can rewrite sine of alpha x minus sine of beta x as the following. Twice of cosine, half of angle sum, right? This plus that. So alpha plus beta quantity x times sine of half of angle difference, alpha minus beta, quantity x. And then we can remember, so in equivalent infinitely small, right, substitution, remember, as x approaches 0, sine of this whole quantity also approaches 0, right? Because 0, sine 0. So remember, it can be substituted with the exact same angle. Because remember, the limit as let me just use y. Y approaches 0 because we've already used x. Sine of y over y. Y is my angle, right? So this limit is equal to 1. This is a well-known limit. So here, this whole quantity is just like my y. So therefore, I can replace sine of this quantity with just the inside angle, right? So my original limit expression can be written as e to the alpha x minus e to the beta x over twice of... also remember, also notice that as x approaches 0, this angle approaches 0. Cosine 0 approaches 1. So this quantity approaches 2. Approaches 2, right? So this is replaced with 2. And this is replaced with just this inside angle. And 2 times the inside angle. 2 and 2 cancel out. I'm only left with alpha minus beta quantity times x. Right? I just need to find out this limit as x approaches 0. But now let's just use Taylor expansion on the top. So alpha minus beta x e to the alpha x can be written as 1 plus now I just treat alpha x as a whole entity, right? Here I plus x, then I should plus alpha x plus little o of alpha square x squared, but it's the same as x squared, little o of x squared. Let's recall the meaning of little o. So little omicron. For example, little omicron of x squared as x approaches 0. What that basically means is that consider this as a whole quantity. This quantity approaches 0 very, very fast. How fast? Meaning, so is little o of x squared. So meaning that this amount, if divided by x squared, also approaches 0 as x approaches 0. Right? Remember, x squared already approaches 0. So it's an infinitely small amount. So some other amount divided by an infinitely small amount still can be infinitely small, meaning that the numerator has to be even smaller than the bottom. Right? So meaning that this quantity really approaches 0 faster than x squared. So, like I said, I was supposed to write little omicron of alpha squared x squared, but alpha is only a constant. Right? So meaning I'm asking myself, right? I was supposed to write a little omicron of alpha squared x squared. Right? So can I rewrite it as little omicron of x squared? It's totally legitimate. The reason is that I need to ask myself, can I show that this quantity approaches 0 faster than x squared? Right? I want to show it can be written as little omicron of x squared, meaning it can be written as an amount that approaches 0 faster than x squared. Right? Meaning, can this amount be divided by x squared and still approaches 0? Right? Can this happen? Yes, because I can rewrite this quantity into, I can multiply both the top and bottom by alpha square. Right? So remember the little omicron, the meaning of little omicron. Right, little omicron of alpha square x square, the bottom alpha square x square. So the meaning of little omicron is that if it's divided by the inside quantity, it still approaches 0. So this whole quantity approaches 0. Multiplied by some constant, is it still approaching 0? Of course, yes. So the answer is, I can really rewrite this little omicron as that little omicron. I can really do that. So this is totally fine, legitimate. Now I need to minus the next quantity, right? Bracket 1 plus beta x plus little omicron of x squared. Then I can just cancel out something, right? Alpha minus beta, quantity x, 1 and 1 cancel out. I'm left with alpha x minus beta x, right? Alpha minus beta, quantity x. And now I have little omicron of x squared minus little omicron of x squared. So we almost want to write 0, but they actually cannot cancel each other out. The reason is because this quantity is not a it's not a fixed quantity. If it were a fixed quantity, then we can just simply cancel them out. But it actually represents a changing, like a kind of dynamically changing quantity, right? Something that's approaching 0. So we cannot just simply cancel them out. So the right way, correct way, is to still write little omicron of x squared, right? In this case, it's their difference. Still write as little omicron of x squared. If it were a plus, right, it's like twice of little omicron, but still can be written as little omicron of x squared, right? Because the meaning is that the reason is because little omicron of x squared minus little omicron of x squared, right? It almost looks like 0, but not exactly 0, right? The reason we can rewrite it into little omicron of x squared still is only because we want to ask ourselves, can this whole quantity, if divided by x squared, can it still approach 0 as x approaches 0? Right? If we can rewrite it into this, meaning this quantity, meaning divided by x squared, still approaches 0. Equivalently, it's equivalent to asking this amount, if divided by x squared, is it still approaching 0? The answer is yes. Because split up the top, it's little omicron of x squared over x squared. Right? Remember the meaning of little omicron, meaning this quotient, this ratio approaches 0. So this approaches 0, minus little omicron over x squared, right? Still approach 0, right? So when you have two infinitely small amount, take their difference, it's still infinitely small, right? Still approaching 0. No, not exactly 0, but still approaching 0. So this is fine to rewrite like this. So in the end, we should have just split up, right? So alpha minus beta x becomes 1. And this becomes alpha minus beta at the bottom. I can cancel out x, little omicron of x. I can do that. Just like do normal algebra. I can do that. The reason is because, so how can we divide the little omicron of x squared by x and rewrite it into little omicron of x? Reason is very simple. We just need to ask ourselves, can this quantity be divided by x and still approaching 0? Right? Because we want to rewrite it as little omicron of x. The meaning of this quantity is that if this quantity is divided by x, then it's still approaching 0. Right? So we need to ask ourselves, can this quantity be divided by x still approaching 0? Right? So divided by x times, so x squared, can x still be approaching 0? The answer is yes, because the top is little omicron of x squared. The meaning of little omicron of x squared is that if it's divided by the inside quantity, it approaches 0. So yes. So really, it can be divided like that. Rewrite it into omicron of little omicron of just x, just like doing normal algebra. Right? This is fine. So the bottom is some constant. The top is a little omicron of x. Little omicron of x meaning if it's divided by x, still approaches 0, meaning it's approaching 0 faster than x approaches 0. So x is already approaching 0. Then little omicron of x, of course, even more approaching 0. Even more smaller, right? So this is already very, very small, right? So infinitely small, of course. So really, this whole quantity is approaching 1 as x approaches 0.